Hi, welcome to Design Strong. Today in this video we'll try to understand what is n-tier architecture. So basically we'll try to understand what is a two-tier architecture and what is three-tier architecture. We'll keep it simple, we'll keep it short, and we'll try to keep a background on what really happens, and we are focusing on making it very easy for everyone to understand. So we'll start from the basics, and guys, keep a note that this is a building block for creating a large scale system. So just do not miss out this video, because this is going to be very important in the course of upcoming videos of this series. Hi, so in this video we'll try to understand the client server architecture. The client server architecture is the basic building block for understanding system design. This is the old school thing wherein we should try to understand the basics first and then probably come to advanced level topic. So let's get started. What is a client? So first of all, before we understand anything, we should understand what a client is when we say client server architecture. So client is nothing but it can be a PC, a workstation, a laptop, a mobile phone, or any smart sort of device on which user runs an application. Client is generally somebody who will rely on server for resources, and these resources can be anything such as processing, program logic, getting some files, doing some device operations, etc. There is another type of network architecture which is known as peer-to-peer instead of a client server. So in client server, basically what happens is there can be multiple clients, there can be one server or even multiple server in some cases when we have load balancer. Whereas in peer-to-peer, every node has equal responsibilities. There is no sort of a client who's waiting for server. What is a server? A server is nothing but understand server as a powerful computer or a processing capability which is dedicated towards managing some sort of application program, logic, database, and anything which is happening behind the scenes. So application logic would mean here is that what should be done whenever there is a request from client which is coming. Request and response means the formats in which the client will send the request and the format in which the server should respond so that client is able to understand it. Simple, because we will provide only a single sort of request response contract between client and server, and the computation will happen behind the scenes. So for client it is very simple, send a request to server and get the response. Now comes the big picture. What is a client server architecture? So client server architecture, if you have to understand it from an applications perspective. So applications are usually modeled around set of services which runs on some sort of servers, and there will be clients who will be utilizing those services. Now client knows what, like, where the server is, the location in terms of an IP address or whatever address they are using to call the server, but they don't know much more details apart from this. Similarly for server in general does not require to know the status of client except for some of the user info that might be needed from clients. Client and server both have logical processes. So client will have some logic based on which they'll send the request to server, and server will have definitely some business logic on basis of which every request should be provided with a response. If we talk about client server architecture, generally there is two-tier and three-tier architecture. Togetherly we call them as n-tier architecture as well. So here in two-tier architecture, basically there are three layers in both the structures, but in two-tier the three layers are mapped on two computer systems, and these computer systems are like, so it's like only two tiers. One is an application layer which generally will be on client side, and then server will have both a database and application logic. Clients here can be thin client and thick client, or even known as flat client. So if you want to understand what is thin client or what is a fat client, we'll discuss that as well. In three tiers, generally what happens is there will be logical separations in processes at three levels, and usually these three layers will be running on different processors. When we say processors, this could be different remote machines, different servers, and or different partitions on a single server. Thing to notice is that nowadays 2 tier and 3 tiers both are outdated. When I say outdated, it does not mean that these are not used. It's just that when we try to design something on a large scale, then 2 tier and 3 tiers are not preferred. Like I said, we need to understand what is a fat or a thin client. So fat client is, understand it this way, fat client is a client with a fat belly. That means they'll have some heavy logic which will be running at client's end as well, and then whenever needed they'll be asking for information from server. Usually desktop games or mobile games these days are examples of fat lines, wherein for example you might have played games which are in order of GBs, so those are example of fat line. In thin client, these are also known as lean clients basically. So it means that they are basically having no or very less logic at their end, and they only depend on servers for doing the processing. That is, they'll in most cases will send requests to the server will do the heavy operations and return back the response. One example for this is Outlook, wherein all the logic happens on one of the Microsoft based servers, which can be a rack or something, and rest of it is like only very few operations are done on Outlook side. Understanding the 3-tier architecture a bit more, it's like there will be 3 layers: application layer, which is nothing but the UI, then there will be a business layer which will be having the logic, and then there will be a database at backend. So those are the 3 tiers basically. Each of these layers will be executed on a different processor. This helps us to give a better performance because client is separate, and it's easier to manage. Logical changes can be done from the server end directly, and usually when compared to 2-tier architecture, this is more scalable. Why? Because when 3 layers are on different processors, we get a bit of horizontal scaling. Then this provides us with different sort of processing power, which is way more than 2-tier. So we will try to see what is horizontal scaling, vertical scaling. Don't be surprised, guys, if you don't understand these concepts at this point in time. Typical example of a 3-tier architecture. First tier is the client or the user interface. So this could be, for example, let's consider this as an example. So you are using Outlook. So this Outlook that is installed on your system is the first tier, which is the user interface or the presentation layer. Second is the application server. Generally these second and third tier are on the server side. So application layer will be responsible for all the business logics which will be built, like what to do when this request comes, and then there will be a third layer which is usually known as data layer or database, which will be responsible for handling, saving and providing data back to the application layer, which can be processed. So this is simple example. First tier in this 3-tier, first tier is the client, and second and third tier togetherly forms the server. In 2-tier, it's like the second and third layer will remain on the same server. So for example, if I have an application, or let's say if I have a website which is running, so the browser based client is who's browsing is the first layer, which is client, and let's say if the database and the application logic are on the same server, it becomes a 2-tier architecture, and both the layers are on the different sides. So one is client, one is server. Advantages is, we do not need to maintain that sort of network between the application layer and database layer. Disadvantages, performance can be an issue. Let's say if database gets heavy with time, it can lead to deprecating performance of the business layer as well. One tip here is for multi-threaded applications, often it is seen that 2-tier architecture will definitely have some scalability issues. Why? Because in multi-threaded applications there will be multi-threads which will be working at any point in time, and that can lead to performance degradation because we have limited CPU to utilize, and that needs to be divided carefully between the entire server. This is a typical example of two-tier architecture. So let's say if I have a heavy game which is here, and it has both logic and user interface, and it for some sort of data saving, it relies on server. So second tier becomes the data server. This may or may not contain the business logic, because usually in two tier this is a fat client, but seldom we have seen that there is logic at this end as well. Just to know, like, this might sound very boring, but you have to understand it this way, that the problems that the world had with two tier and three tier architecture is what led to a microservices based architecture. So understanding these, like, a bit of it helps in understanding why people went around discovering microservices. So what will be next on our tutorial session is, we'll see what is microservice architecture, and we'll try to understand the difference between monolith and microservice. So in case if you are not aware, what we discussed here, N tier, which is 2 tier, and 3 tier, is also known as a monolith based server, and we'll see what microservices is in the next session. Then one more thing is, there is no hard and fast rule of you trying to use microservices everywhere, because they have their own complexity, and one should understand that if there is a problem that can be solved with a monolith, having a microservice will definitely add to cost and performance, and like, one should not give more resources than actually needed. So in terms of optimization, there can be issues, but whereas in case if you are trying to build an application which is going to solve, let's say, 1,000,000 requests per second, or even in the order of 10 of thousands, then we should look at microservices.